Exposed to the elements, raw iron rapidly surrenders to the moisture and air around it, corroding into decay. Yet, right next to it, a different surface can endure those exact same conditions and remain flawlessly intact. The dividing line between rapid deterioration and permanent preservation is element 24, chromium. This single metal occupies a strange space in chemistry. It is responsible for some of the most vibrant, permanent colors in the natural world, while simultaneously harboring a highly toxic chemical state. The scientific understanding of this metal begins in 1797, when French chemist Louis-Nicolas Vauquelin set out to investigate an unusual geological specimen. Vauquelin isolated a completely unknown element from a bright red-orange mineral called crocoite. Because its chemical compounds produced such striking, vivid pigments, he named his discovery after the Greek word for color, chroma. The question is, how a substance isolated entirely for its artistic potential eventually became the invisible structural backbone of modern global infrastructure. During the rapid expansion of early heavy industry, engineers faced a relentless problem. The massive iron and early steel structures they relied on to build factories and transport networks were highly susceptible to atmospheric corrosion. The metallurgical solution arrived when engineers tested the effect of mixing chromium into steel. By adding at least 10.5% chromium by mass, they altered the surface chemistry of the metal. As oxygen strikes the surface, chromium reacts instantly, forging a thin protective shield called a passive oxide film. If scratched, the metal protects itself. Newly exposed chromium uses available oxygen to rapidly seal the breach, reforming the barrier. This self-repairing mechanism allowed architects to construct gleaming spires that could withstand decades of harsh weather, rain, and pollution without tarnishing. It also solved a critical issue in medicine. Surgical tools forged with chromium could endure the harsh chemicals and intense heat of repeated sterilization without degrading or rusting over time. Eventually, this same corrosion resistance scaled down to domestic life, providing the hygienic, durable surfaces required for modern food processing and everyday kitchen appliances. By physically blocking oxygen from devouring the underlying iron, element 24 elevated ordinary steel from a temporary building material to a permanent foundation. While it dominates industrial engineering today, element 24 maintains its deep connection to its namesake, chroma. For centuries, chemists and artists extracted its compounds to manufacture incredibly potent paints and dyes, particularly the deep, lasting shade known as chromium oxide green. Nature utilizes this exact same chemical mechanism. Deep underground, the brilliant green hue of natural emeralds is caused by minute amounts of chromium trapped inside the growing crystal structure. A microscopic fraction of this element transforms an otherwise pale, ordinary mineral matrix into a vibrant green gemstone. The exact same atomic properties that armor brutalist skyscrapers also dictate the vibrant color of a delicate crystal. However, chromium's behavior is entirely dependent on its oxidation state, the specific arrangement of how it shares its electrons. In its naturally occurring, stable form, known as trivalent chromium or Cr3, it is safe enough to play a trace role in human nutrition. But when the element loses more electrons to become hexavalent chromium, or Cr6, it transforms into a highly toxic carcinogenic state. This dangerous configuration rarely occurs naturally. It is almost exclusively a byproduct of human intervention, generated during intensive manufacturing processes, like metal finishing and pigment production. Historically, industries like traditional leather tanning utilized vast quantities of these compounds, creating open chemical vats that severely impacted the health of workers and the surrounding environment. Chemistry contains no inherent morality. The danger of a substance is dictated entirely by its atomic concentration and the methods humans use to manipulate it. Today, element 24 exists as a contradiction. It is an absolutely essential industrial protector that simultaneously requires strict environmental regulations during manufacturing. Its behavior provides a larger lesson about the periodic table itself. These elements are not static blocks of matter, but a dynamic map of chemical possibilities. If humanity alters its chemical form by just a few electrons, the precise element that forms an impenetrable shield immediately becomes a deadly hazard. Chromium gave us the power to build a lasting, stainless world, serving as a permanent reminder that the forces of chemistry must be thoroughly understood and deeply respected. If you want to continue exploring the hidden mechanics of the elements around you, follow Atomic 118, like and share. Next time, we look at an element with an even more unexpected story.